With regard to ray optics, you should know what is reflection. Reflection abdinaka, a ray of light is falling on a mirror. Reflecting surface is a mirror. Okay, mirror varayirudana they'll always put like this to show that one side is polished, so that your ray is like coming like this. This is the incident ray. At this point of incidence, you should always have a normal perpendicular, and this is your angle of incidence. The incident ray makes with the normal. This is the reflected ray. It's getting reflected back into the same medium because it's a glass. This is angle of reflection, which is again made with a normal. So this is how reflection happens. Reflections happen only the mirror surface. Mirror surface the reflection will happen. And you know this angle of I is equal to R. The angle of incidence should be equal to always angle of reflection. And the laws of reflection, these are 10 standard portions. So laws of reflection states that the incident ray, I'll do it in red color, the incident ray, the reflected ray, and the normal, which are at the point of incidence. Normal is drawn at the point of incidence, are all in the same plane. First law states that angle of incidence is equal to angle of reflection. The second law states that the incident ray, the reflected ray, and the normal at the point of incidence, all of them lie in the same plane. This is known as laws of reflection. In reflection, if you see, the ray is coming in air and going back into air. It's the same medium. So you know speed of light in air is c, and it's also going back, speed of light in air is c. The speed does not change. So let's talk about refraction. What is refraction? When you need a medium, a glass slab or something. Okay, so then therefore, when a light ray is entering from air, this is incident ray. Always remember, at the point of incidence you have to do a normal. The light ray is entering from air into glass here. So it's entering from rarer medium into a denser medium, which means obviously it will bend towards the normal. Always when it comes from rarer to denser, it bends towards the normal because the speed will get decreased. Air is ரொம்ப ஃபாஸ்ட்டாக போகும், கிளாஸில் கொஞ்சம் கம்மியாக போகும். So you know, இங்கே velocity of light in air is c. And here velocity of the ray in medium is v. It's not c. It will be lesser. 3 into 10 to the power 8 is the maximum speed. Meter per second is the maximum speed. Airல இருக்கும்போது அவ்வளோ ஃபாஸ்ட்டாக வருது, கிளாஸ்குள்ளே நுழையும் போது the speed will get reduced. And this phenomenon by which the light is traveling from one medium into another medium is called refraction. So what is the angle of incidence? Is the angle the incident ray makes with the normal. What is angle of refraction? The refracted ray makes with the normal. So you understand? So in this, here you know the first law I is equal to R. The second law in the previous one is incident ray, reflected ray, and the normal at the point of incidence, all of them lie in the same plane. This is laws of refraction. Laws of refraction. What can you say about laws of refraction? You know, refractive index. Refractive index is nothing but sin I by sin R. This law is called Snell's law. Again, these are all 10 standard basics. Okay, Snell's law states that the refractive index is the ratio of the sine of the angle of incidence to the sine of angle of refraction, correct? Sin I by sin R. You can also say, this is one way of saying. Another way of saying refractive index is also speed of light in medium, speed of light in vacuum by speed of light in medium. So speed of light in vacuum will be highest value. So denominator will always be lesser. So then therefore I'll say refractive index of water is 1.33. Refractive index of glass is 1.5. Refractive index of air or in vacuum is just 1. Okay, something like that. Okay, so then there are refractive index for every medium, especially water and glass. You need to by heart 1.33 and 1.5. Are you clear? So then so you know the speed of light in vacuum by speed of light in medium. Okay, so let me write this. Refractive index of water with respect to air. Water with respect to air. Abdina, light rays coming from air into water. So you are writing refractive index of water with respect to air, and the value is 1 point. It is also mu of water by mu of air. Mu of water is 1.33. Mu of air is 1. So the answer is 1.33. Refractive index of glass will be with respect to air because it's entering from air to glass, which will also be mu of glass by mu of air. Mu of glass is 1.5 by mu of air is 1, so it's 1.5. So even detailed vena, you just have to know that this is mu of water. Mu of water nali it's with respect to air na idla. Okay, so it's 1.33 and this is 1.5. This is speed of light in vacuum, which will be V and which will be C. Vacuum means C, no? By speed of light in medium, which will be V. So you know this formula is C by V. And you should also know that velocity is distance by time. 1 by t is frequency. Distance is lambda because it's like a wave, treated as a wave. You know that velocity is lambda into frequency. Do you know this? Distance will be wavelength. And 1 by t is nothing but frequency. Reciprocal of time is frequency. So therefore you can write velocity as lambda into mu, frequency, lambda into frequency. So here it's lambda in vacuum into frequency in vacuum by velocity in medium, lambda in medium and frequency in medium. I'm going to tell you something very important. The frequency does not change while it's traveling from one medium to another medium. Only the speed changes, which means only the wavelength changes. Nalla purinjukko. Speed changes now, what changes? Only the wavelength changes. The frequency does not change at all. Frequency does not change at all. So there's no frequency in vacuum and frequency in medium. It's all the same. So it's going to be the same. The frequency in vacuum and frequency medium also is also vacuum. Same. So it's going to be cancelled. Therefore you have another formula which is wavelength in vacuum by wavelength in medium is also refractive index. Therefore you understand that refractive index is inversely proportional to wavelength, because wavelength in vacuum will be a constant value, wavelength in medium is what is going to change. So depending on this, the refractive index and wavelength are inversely proportional. Are you clear? So between red light, VIBGYOR, you know VIBGYOR, red light and blue light, let's see which has got a greatest wavelength. Red has got a greatest wavelength. Another red வந்து signal use பண்றாங்க, because it can travel long distance and you stop the vehicle, whereas the green signal, red, blue கிடையாது of course, green, but you know red has the longest wavelength, blue has got the shorter wavelength. Red can travel longer distance because it has got a greater wavelength, whereas blue has got a shorter wavelength. Do you understand? So wavelength of the red light is the maximum, so wavelength of the blue light is less. Okay, it goes like this: VIBGYOR, VIBGYOR, where red has the maximum wavelength, then kammi aayite varum. Blue inga irukku, violet has the least wavelength. The VIBGYOR written like this, where red has the you understand what I'm saying, longest wavelength. So then therefore you know that if you're talking about a refractive index for a red light has got the greatest wavelength, so refractive index will be least for red, and the blue light is lesser wavelength, therefore it has got the maximum. So you should understand this line, very important, that the refractive index is inversely proportional to wavelength. Are you clear till here? Play it again and again and become clear so that I don't have to do it now. So then this is what it is. These are the basics. Okay, so I'll just try the sum, which is example 13 in Aurora. So let's do example 13 in Aurora. A ray of light of frequency 5 into 10 to the power 14 hertz is passed through a liquid. So you're passing this frequency into a liquid. The wavelength of the light measured inside the liquid is found to be inside the liquid, which means wavelength in medium. Wavelength in liquid is nothing but wavelength in medium is 450 into 10 to the power, can you tell me, minus 9 meter. What is given first? The ray of light with frequency. What is the meaning of frequency when passed through liquid? Frequency in the medium. Do you think there is something called frequency in the medium? I just told you frequency in air and frequency in the medium will be the same, which means frequency in the medium is also frequency in air, general frequency. So what is the first to clear akiko? Then they've given the wavelength in the medium is 415 10 to the power minus 9. Calculate the refractive index of a liquid. So they're asking for refractive index of the medium, which is the liquid, with respect to air. And I told you the formulas such as sin I by sin r, Snell's law, we can't use it. There's no incident ray or refracted ray. I can't use that formula. What is the other formula I can use? Velocity of light in vacuum by velocity of light in the medium. So you know that I can also write this velocity as wavelength in vacuum into frequency in vacuum by wavelength in medium into frequency in medium, which is also frequency in vacuum. So the frequency does not change during refraction. Only the wavelength and the speed changes. Okay, so then therefore, what do you have? You have wavelength in the wavelength in medium is there already given, and they have given the frequency in air. Frequency in air with frequency in medium is given, which is nothing but frequency in air. With that you can find the wavelength in air, because you want wavelength in vacuum, which is nothing but wavelength in air. You should remember this formula. Mu is equal to c by lambda. You know, velocity is distance by time. Okay, this mu is different from this mu. This is the refractive index mu. Don't confuse yourself. This is refractive index. This is frequency mu. Are you clear the difference between this mu and that? This is refractive index, that is frequency. And velocity is equal to distance by time, which is nothing but v is equal to lambda into mu. Or you can also say c is equal to lambda into mu. So if you want lambda, you can write c by mu. Lambda is equal, c is equal to lambda into mu. So lambda is equal to c by mu. So if you want to find the wavelength in air, you can write the velocity in air by frequency in air. So 3 into 10 to the power 8 by 5 into 10 to the power 14. You calculate this answer, you will get that, which is nothing but wavelength in vacuum, or wavelength in air is nothing but wavelength in vacuum. Appade kondu inga potru. So you will know this also, you know this also. So you can calculate the refractive index of the liquid. Are you clear? இதே நமக்கு இன்னொரு அப்ரோச் சொல்கிறான் சந்தோஷ். என்ன சொல்கிறான்னா, மேலே சீன்னு தெரியும், சீனே வச்சுக்கோங்க, ஒன்றுமே பண்ணாதீங்க. கீழே மாத்திரம் வேவ்லென்த் இன் மீடியம் இன்ட்டு ஃப்ரீக்வன்சி இன் வேக்யூம்னே போட்டுக்கோங்க. ஃப்ரீக்வன்சி இன் வேக்யூம் அவனே கொடுத்துட்டானே டைரெக்டாக. ஸோ இந்த இடத்துல 5 into 10 to the power 14 எழுதிக்கலாமே. வேவ்லென்த் இன் மீடியம் அதுவும் அவனே கொடுத்துட்டானே, விச் இஸ் 450 into 10 to the power -9 அதையும் கொடுத்துட்டான். இது 3 into 10 to the power 8 இப்படியே கூட டைரெக்டாக கண்டுபிடிக்கலாம். எஸ், திஸ் இஸ் ஆல்சோ ரைட். This is also right. You can do whichever way, and this is a brilliant way, in fact, because that saves me from lot of other workings. So it's brilliant. So try to continue doing like this. Think about your own options and do it. But this formula you should know. The formula is mu is equal to c by lambda. Mu is equal to c by lambda. So ipo question is only about find only the wavelength in vacuum. Now unku indha formula theriyada mudiyadilla. Suppose correct ah. So adukku answer vanuna indha formula theriyum. நீ பண்ணது கரெக்டான இது தெரியணும். ஸோ மியூ இஸ் ஈக்குவல் டு சி பை லாம்டானா லாம்டா இஸ் ஈக்குவல் டு சி பை மியூ. ஸோ வித் திஸ் யூ கேன் ஃபைண்ட் வேவ் லென்த் இன் ஏர். எனி ஹவ் யூ டூ இஸ் அப் டு யூ. ஐம் ஜஸ்ட் டீச்சிங் யூ ஒன் வே. இஃப் another thing strikes you, please do it. Are you clear with this sum? Very, very important. Let's go to next question. The light of wavelength 4500 Armstrong. 4500 Armstrong na 4500 into 10 to the power -10 meter. In vacuum, so this is in vacuum, enters a glass block of refractive index 1.5. What is the frequency and wavelength of the light in the glass block? So they are asking frequency in the glass and also wavelength in glass. You know the formula for refractive index, I just taught you, which is C by V. Okay, நீ சொன்ன மாதிரி நான் மேலே 3 into mu தெரியும் எனக்கு. Mu is 1.5. C வந்து 3 into 10 to the power 8. இதை வச்சு நான் வியை கண்டுபிடிச்சிடறேன், விச் இஸ் வெலாசிட்டி ஆஃப் லைட் இன் தி வெலாசிட்டி ஆஃப் தட் இன் தி மீடியம். கரெக்டா? மீடியம் வேர் வெலாசிட்டி லாம்டா இஸ் கிவன், விச் இஸ் இன் வேக்யூம். ஐ டோன்ட் வாண்ட் வேக்யூம் அட் ஆல், பிகாஸ் நீ சொல்கிறபடி பண்ணால் எனக்கு வேவ் லென்த் அண்ட் வேக்யூம் இதில் யூஸ் ஆகாது. கரெக்டா? ஸோ வித் திஸ் ஐ கேன் ஃபைண்ட் த வெலாசிட்டி இன் தி மீடியம், which is 3 into 10 to the power 8 by 1.5, which will become 2 into 10 to the power 8 meter per second. I get the velocity in the medium. And I told you, what is the formula for velocity? Is wavelength into frequency. Wavelength into velocity is distance by time, which is wavelength into frequency. So you know velocity of the medium. You know, frequency does not change because frequency in air and glass are the same. Have they given the frequency? No, they given only wavelength in vacuum, with which you have to find the frequency in vacuum, for which you need the formula, which is nothing but, what is the formula? Velocity is equal to, mu is equal to c by lambda. So if you, mu is equal to c by lambda, so you want wavelength frequency in vacuum, it's 3 into 10 to the power 8 by 4500 into 10 to the power minus 10. With mu is equal to c by lambda போட்டா எனக்கு என்ன கிடைச்சிருது? Frequency in vacuum. அதை அப்படியே எடுத்துட்டு வந்து இங்க போட்டுலாமா? Because the medium la frequency is not going to change. So you can, do you know the velocity in the medium? So fill 2 into 10 to the power 8 is equal to lambda in the medium into frequency, which is general frequency, which you can substitute this here. 3 into 10 to the power 8 by 4500 into 10 to the power minus 10 போட்டா you can get lambda. That will give you, இதான் பண்ணணும் கிடையாது, இது நான் எப்படி பண்றேன். Any other easy method strikes you, please go ahead and do it. There's no fixed way. Okay, this is wavelength in medium. What are they asking then? The wavelength of the light in the glass block. Frequency. Frequency does not change. It's the same as what is in the air, and I invariably found it already. I already found out. Using the wavelength in vacuum, I found out the frequency in vacuum using the formula mu is equal to c by lambda. Are you clear? So I'll do example 16. So example 16, a ray of light passes through a plane boundary separating two media whose refractive indices are, there is one medium which has got refractive index 3 by 2. There is another medium which has got refractive index 4 by 3. So a ray is entering from a boundary of two media. So one has got that refractive index, one has got, this is medium 1 and this will be medium 2. If a ray travels from medium 1 to medium 2 at an angle of incidence 30 degrees, so what an incident ray? You need to immediately normal at the point of incidence, and you know this angle is 30 degree. Okay, 30 degree. When it travels into angle of incidence 30 degree, what is the angle of refraction? What is the angle of refraction R? And you know mu is equal to sin I by sin R. But in the mu another, it's a second medium with respect to first medium here, which is nothing but mu of the second medium by mu of the first medium. Correct? Is equal to sin I by, sin I is what? 30 degree. Sin I by sin R. What is mu 2? 4 by 3. What is mu 1? 3 by 2. Okay, the light ray is entering from rarer into denser, then this formula is correct. When it's entering from rarer to denser, mu is equal to sin I by sin R is correct. So mu of 2 with respect to 1 is correct. So 4 by 3 by 3 by 2 is equal to sin I, which is sin 30 by sin R. You can find out cross multiply. What is sin 30? Sin 30 is 1 by 2. So you can just do the calculation and get the answer for sin R. Are you clear? So then that's about it. Next part of the question. If the ray travels from medium 2 to medium 1, the travel from medium 1 to medium 2. In the second case, it is going to travel from medium 2, which is a denser medium, to medium 1, which is a rarer medium. The light is entering here, and the normal is at the incidence. When it's entering from denser to rarer, it will move away from the normal. This is your I, this will be your R. What is the refractive index of second medium? We saw it is 4 by 3. Mu 2 is 4 by 3. What is the refractive index of first medium? We saw it to be 3 by 2. Correct? Now since it's entering from denser to rarer, I can't write mu is equal to sin I by sin R. I have to write 1 by mu is equal to sin I by sin R. Whenever it's entering from denser to rarer, it's 1 by mu is equal to sin I by sin R. Whenever it's entering from rarer to denser, mu is equal to sin I by sin R. Clear? Teacher சொல்றது குழப்பிக்காதீங்க. Write it like how I'm saying. So it's 1 by mu is equal to sin I by sin R, which is always, for me, mu is always 2 with respect to 1. That does not change. I don't switch that 1 and 2. I'll always keep it as 2 with respect to 1. But instead I'll write 1 by. Because 1 by mu of 2 with respect to 1 is nothing but mu of 1 with respect to 2. Instead of that I will write 1 by. So so that it's easier for me. I don't want to zigzag confuse that 1 and 2. I'll keep it as 2 with respect to 1. If I want to change the medium, then I'll write 1 by. If it's denser to rarer, it's 1 by mu is equal to sin I by sin r. Correct? What is angle of incidence? What is the angle of refraction? Oh, so the angle of incidence here is same 30 degree it's entering. They're asking for angle of refraction. And you write 1 by mu. What is mu? Normally you write mu 2 by mu 1. Here you have to write mu 1 by mu 2 because it's reciprocal. So it's actually 1 by mu 2 by mu 1. Therefore it will become mu 1 by mu 2 is equal to sin I by sin r. What is mu 1? 3 by 2. What is mu 2? 4 by 3. Correct? Is equal to sin I, you know, is 30 degree by sin r. And you know 30 degree is nothing, sin 30 is 1 by 2, just calculate and get the value of r. And you know in this r will be much greater, whereas here r will be much lesser. You understood how to do it? Okay, so let's go to next question. Example 17 is what I'm going to do next. A rectangular glass slab rests at the bottom of the trough of water. So let's draw a trough of water. இதில் ஒரு rectangular glass slab is lying underneath. தண்ணிக்குள்ளே இருக்குது, இது ஃபுல்லும் வாட்டர் இருக்குது, அதுக்குள்ளே rectangular glass slab. Bottom, a ray of light incident on the water surface at an angle of 50 degree passes through water into glass. So மேலேந்து வந்துட்டு it's entering in and then it's going to get into water. Normal. So it is going to bend towards the normal because it's entering from a rarer medium into a denser medium, which is water. This is air. So it's bending towards the normal and goes and falls on the glass slab. Again, in the glass slab, we should have one more normal because this is the incident ray, correct? And you know, it's further going to bend towards the normal because this is glass, even denser than water. So it's going to bend so much inside towards the normal. Are you clear? So this is how I construct the diagram, and they've given that this angle is 30 degree. The angle at which it is incident 50 degree. Okay, the angle at which is incident normally 50 la kudukka matanga, 30 da kudupanga school la. Okay, 50 degree. Okay, a rectangular glass slab rests on the bottom of the ray of light incident on the water surface at an angle of 50 degree passes through water into glass. Calculate the angle of refraction in glass, which means the question is R in glass. This is the question. Refraction in glass, given that the refractive index of water is 4 by 3 and the refractive index of glass is 3 by 2. We already know 1.33 and 1.5. Namakke theriyum. So you can also write it as 4 by 3 and 3 by 2. But they will give it. If they give it, no problem. Now you have to find what is R. Okay, let's explore this sum. First, let's find this. This is 50 degree, right? So we can find this R. Because here it's entering from air to water. So what is the refractive index formula? Mu is equal to sin I by sin r. No 1 by mu. Because it's entering from air to rarer to denser. Mu is equal to sin I by sin r, where it's water with respect to air. What is water's refractive index? 4 by 3 is equal to sin 50 by sin r. So when I cross multiply, I'll get the sin r. So let that sin r be some angle approximately 35.06. 35.0. I told you, they won't give 50 degree, they'll give you 30 degree. So that refractor angle you can find, it will be 45 degree, something known angles only, it won't be unknown angles, okay. So you find this angle. Once you find this angle, which is, let's keep it as 35 degree for now. சும்மா வச்சுக்கோ 35. இது 13 வச்சுனா நல்லா இருக்கும். சரி 35 டிகிரின்னு வச்சுக்கோ. இப்போ இது தெரியும் 35. Interior alternate angle, this will also be 35. Z angle. So the angle of incidence in the glass slab is 35. And it's going to enter into R, and you have to find this. Okay, here it is glass and above which there is water. So you have to write the refractive index of, is it entering from rarer to denser? Water to glass? Yes. So mu of glass with respect to water. Because it's entering from water to glass, you have to write mu of glass with respect to water, which is mu of glass by mu of water. What is mu of glass? 3 by 2. What is mu of water? 4 by 3, which is what is equal to sin I by sin r, which I is this I? This I, what's happening in the glass slab, correct? What is sin I there? Sin 35 by sin r, you don't know sin r, but you know 3 by 2, 4 by 3, sin 35. You can calculate. Are you clear? So slowly you should get it inside. Slowly every refractive index you should write. And here alone, in this medium alone, you should know it's entering from water to glass. So the refractive index will be with glass with respect to water, and is entering still from rarer to denser. So I don't have to put 1 by mu. I can put mu of glass with respect to water, which is mu of glass by mu of water, which is nothing but sin I by sin r. That sin I you should find out. You can't take this I. Slowly you should use that and find. Are you clear? So can I go to next sum? So with these concepts, this is the intro concept. If you're clear, you'll be able to do some basic sums which are 1 mark or 2 mark questions. The next concept is the glass slab experiment. You've done this. Glass slab will be there. There will be an incident ray. I'm taking the derivation. At the point of incidence, you will have a normal. Extend the normal like this. So it's entering from air into glass. This is air and it's entering into glass, so it will bend towards the normal. At this point of incidence also, you need one more normal. It is going to enter from glass into air, so it's going to bend again away from the normal, correct? So if this ray, if there was no glass slab, would have proceeded like that. The glass slab illena, this ray would have gone straight like that, correct? Do you want me to do it once again? So you have a glass slab, there's an incident ray. At the point of incidence, you have to draw a normal. The light ray is going to bend towards the normal because it's entering from air into glass. Say, just answer. Then at this point of incidence, again you need to have a normal. It's entering from glass into back again air, which means it's going to bend away from the normal, which means this ray, the incident ray would have gone like this if there was no glass slab, which means it's displaced by like this. This is lateral displacement D. Laterally displaced. It's called lateral displacement. Lateral displacement. Are you clear? Through a glass slab. Okay. So you know you have to mark I. I is the angle of incidence. The incident ray makes with a normal. Mark R. This is the reflected ray. Refracted ray makes with a normal. An interior alternate angle. Can we call this also as therefore R? Zigzag, correct? Z mari irukku. This will be angle of emergence. Correct? For change, let's call this as okay, I'm going to put a red color cross mark. Very, very important. Can you see this is a cross mark here? Correct? Let's mark this now as R1 and R2 for now. So let's keep, this will be I minus, this small angle in here will be I minus R1, the gap. And that is enough for me. I don't want anything more because I'm trying to find this D and I have this triangle here. The whole objective is to find the lateral displacement D, and I want only sin I minus R, which has got opposite as D and hypotenuse. Okay, the thing is the glass slab oda thickness dhaan kuduthirukkom. In the point A nu edhiko, in the point B nu edhiko, in the point N nu edhiko, normal vandu N nu edhiko. A theriyum B theriyum, that's hypotenuse. That is not T. Only A N is T. But still I can't use T because I only know this side D. And I can only use the hypotenuse. I can only use the hypotenuse because this is 90 degree. Are you clear? So therefore I can do sin I minus R is equal to opposite, which is D, by hypotenuse. But I don't know hypotenuse. So I have to use the other triangle and do cos R. Cos R will, from this triangle, will be the thickness of the glass slab T by the hypotenuse. Therefore, hypotenuse will be T by cos R, and I can substitute that here. So what will happen here? It will be D by T mele cos R is equal to sin I minus R. What is the purpose to find? D. Just cross multiply. D therefore is T into sin I minus R by cos R, and you should memorize this formula. Lateral displacement D is sin I minus R by cos R. Are you clear? And the red color la cross podradhu adu I idu R na adu I minus R, R1. So and the right triangle eduthitta dhaan displacement varum. So sin I minus R is equal to D by hypotenuse, but I don't know hypotenuse. So take the adjacent triangle, find cos R so that you get the hypotenuse. So T in the formula, T into sin I minus R by cos R is known as lateral displacement formula. You should know the derivation also. Okay. So now that you know this concept, I'll teach you some in this concept, which will be example 18. A parallel sided glass slab of thickness 6 centimeter. Of thickness 6 centimeter na thickness is made of a material of refractive index √3. When the light is incident on one of the parallel faces at an angle of 60 degree. Normal varenula? At an angle of 60 degree. The refractive index of the material is √3. Then when the light is incident on one of the parallel plates at an angle of 60 degree, it emerges from the other face. Find the lateral shift. Lateral shift கேட்குறான். So then இப்போ diagram complete பண்ணோம், bending towards the normal, then again one more normal here, correct? And it's going to enter away from the normal, and you know this is how it's going to be. And they're asking not for this will be R, and we will do a cross like this, remember, and it will be sin I minus, this ray would have gone like this if there was no glass slab. This is what is lateral shift. Again திருப்பி சொல்கிறேன், this cross mark is what is, this will be I minus R, so 60 minus R, that becomes 60 minus R. And the lateral shift ஓட ஃபார்முலாவே எழுதலாமே, இப்போ தான் மக பண்ணிக்குமே, D is equal to T into sin I minus R by cos R. பட் இது R தெரியாது. R தெரியாதுன்னா இட்ஸ் என்ட்ரிங் ஃப்ரம் ஏர் டு கிளாஸ். ரிஃப்ராக்டிவ் இண்டெக்ஸ் தெரியுமே, அதை வச்சு மியூ இஸ் ஈக்குவல் டு sin I by sin R போட்டுடலாமே. ஸோ மியூ ஆஃப் கிளாஸ் இஸ் ஈக்குவல் டு sin I by sin R, which is sin 60 by sin R √3 எதிக்கோ, அதுக்கு பதிலாக √3 எதிக்கோ. வாட் இஸ் sin 60? Sin 60 is √3 by 2. Super. So √3 by 2 na, √3 and √3 will get cancelled. So you'll get sin R is equal to 1 by 2. Where will R be 1 by 2? 30 degree. So R is equal to 30. So in the R 30 degree கண்டுபிடிச்சிடுறேன். So உனக்கு Rம் தெரியும், இப்போ Iயும் தெரியும். So இப்போ substitute பண்ணலாம். Thickness of the glass slab தெரியுமா? 6 cm. 6 cm na 6 into 10 to the power minus 2 into sin I minus R na 60 minus 30 by cos R. Cos R is cos 30. Substitute the value. Get the answer. How is it? So if unless you know this formula, which is the derivation of the previous one, you can't do this sum. So let's go to next question. The next question is, what are they asking? Find the lateral shifter. Lateral shift is what is D? Yeah, I found it directly, that's all. Nothing. It is written in essay, I don't know what he is writing. So let's go to next question. The velocity of light, 19th question I'm doing. The velocity of light in glass, which is velocity of light in glass is medium, 2 into 10 to the power 8 meter per second. And in air, you know, it's 3 into 10 to the power 8 meter per second. They don't even have to give, you know it. By how much would an ink dot appear to be raised? For this, I have to teach you concept again. So I will stop this sum and will do the concept first. The concept is this. Take a beaker, fill it with water. You have a mark here. இதை நீ இங்கேருந்து பார்க்குற, சைட்லேருந்து பார்க்குற கண்ணு, இதான் கண்ணு. இங்கே சைட்லேருந்து பார்க்கும்போது இந்த இதுலேருந்து வருது, இட் வில் கம் இன் டு வாட்டர் ஃபர்ஸ்ட். தென் யூ ஹேவ் டு ட்ரா அ நார்மல் அட் தி பாயிண்ட் ஆஃப் இன்சிடென்ஸ். Then the light ray is going to travel from denser medium into a rarer medium. So it's obviously going to bend away from the normal. So it's going to appear to come from a point here. The object is appearing to be raised. The object is appearing to be, this is where your object is, this is where your image is. Just construct a straight line like this and mark this as this point of, this is object, this is A, this is B. Let's name it like this. Okay? So then mark it as O, A and B. What is, this explains why a swimming pool appears shallow. நிறைய குழந்தைங்க என்ன பண்ணும், ஸ்விம்மிங் பூல் பார்த்தீங்கன்னா இவ்வளோதான் டெப்த் இருக்கிற மாதிரி இருக்கும், போயிட்டு அதில் குதிச்சிரும். அதனால தான் குழந்தைங்களுக்கு இருக்கிற இடத்துல ஸ்விம்மிங் பூலே வைக்க, இந்த கேட் வச்சு பூட்டிடுவாங்க ஸ்கூலில், செட்டிநாடுலலாம் கூட. ஏன்னா அதுங்களுக்கு தெரியாது, தே வில் திங்க் தட் தெர் இஸ் ஒன்லி வாட்டர் டில் ஹியர். பட் ஆக்சுவலாக நீ மண்டையை விட்டுட்டு இப்படி, இங்கே மண்டையை விட்டுட்டு இப்படி பார்த்தேன்னு வச்சுக்கோங்க, அலாங் நார்மல், யூ வில் கெட் டு சி ஆக்சுவலி தி எக்ஸாக்ட் depth. Okay, so why is it we are able to see now? Because it's along the normal. There is angle of incidence is 0 and angle of refraction is also 0. So you get to see the actual depth. Side up pathina, it will appear to be raised. Okay, and the final formula in that is mu is equal to actual depth by apparent depth. This is the final formula. This is mu is equal to actual depth by அது நம்ம எப்படி டிரைவ் பண்ண போகிறோம்? டிரைவ் பண்ண போகிறோம்னா ஆங்கிள் ஆஃப் இன்சிடென்ஸ் இஸ் ஈக்குவல் டு ஐ, angle of refraction is equal to r, interior alternate angle this becomes I, corresponding angle this becomes r. 1 second record avada? Yeah, so you know the final formula is mu is equal to actual depth by apparent depth. So then and this is I, this is r, interior, can you see z angle? So this is I, this is also I, corresponding angle this is r, this is also r. இது ரொம்ப முக்கியம். The light rays here is entering from denser to rarer or rarer to denser? Aye, denser to rarer, because the object is in the bottom of the tank. To reach the person's eye it has to enter from kannla inda ray podu, object la inda ray varudhu kannukku, so it's entering from denser to rarer. So you have to write 1 by mu is equal to sin I by sin. I told you what is it? 1 by mu is equal to sin I by sin r. For me mu is always second denser medium with regard to rarer medium. For me denser with regard to rarer. So when you write that mu is equal to sin I by sin r, normally it's mu 2 by mu 1. Here it will be mu 1 by mu 2 is equal to sin I by sin r, correct? Which is equal to refractive index. But what is sin I from this triangle? Can you take this triangle? What is sin I? Opposite by hypotenuse. Sin I is opposite by hypotenuse. What is opposite? AB. Hypotenuse is OA. So it's AB by OA by what is sin R? Go close இன்னும் வந்து பக்கத்துல உட்காரு. What is sin R? What is sin R? Sin Rங்கிறது இந்த குட்டி triangle தானே, which is opposite, which is AB by hypotenuse, which is IA. So AB by IA. So AB and AB gets cancelled. So you'll get IA by OA, correct? So mu கிடையாதுல, 1 by mu. It's 1 by mu is equal to sin I by sin R. Sorry, I should keep it as 1 by mu ne வெச்சுக்கிறேன், மாத்தவே வேணாம். 1 by mu is equal to sin I by sin R. So it's IA by OA. What is IA? What is the meaning of IA? It's apparent depth. IA va? IA is hypotenuse. IA is the hypotenuse. I don't want hypotenuse. In physics you can take hypotenuse to be approximately equal to height. Sin to be tan. Sin theta can be written as tan I. Sin R can be written as tan R. In மாதிரி நிறைய fraud தான இருக்கும். The angles are small னா அப்படி கன்சிடர் பண்ணிப்பாங்க. So then now it will be I equal to I. IA க்கு பதிலா you can write the height. IA க்கு பதிலா you can write IB. And OA க்கு பதிலா you can write OB. So IB is the apparent depth. OB is the actual depth, correct? So this is 1 by mu. Therefore mu itself is actual depth by apparent depth. Did you understand how I got this? Very, very important derivation. If you know this derivation, then you can do this sum. So let me do this sum now. The sum is the velocity of light. This one only, no? Yeah. The velocity of light, 19th question. In glass is 2 into 10 to the power 8 meter per second. And that in air is 3 into 10 to the power 8 meter per second. By how much would an ink dot appear to be raised? Supposing there is an ink dot, how much would it appear to be raised when seen from the side, correct? By how much would rate it's covered by a glass plate. Oh, this is water. No, it's not like that. This is a different sum. You have an ink dot on which you are placing a glass plate. ஒரு கிளாஸ் வைக்கிற, ஒரு கிளாஸ் வச்சுட்டு அதுக்கு அடியில் இந்த மொபைல் கடியில் ஒரு டாட் இருக்கிற மாதிரி. இமேஜின் யுவர் மொபைல் டு பி ஒன் கிளாஸ் பிளேட். புரியுதா? ஸோ தென் தேர் ஆல்சோ இட் இஸ் கோயிங் டு பி ரைஸ்ட் ஒன்லி பிகாஸ் இட் ஹேஸ் டு ட்ராவல் ஃப்ரம் கிளாஸ் இன் டு ஏர் அண்ட் இஸ் கோயிங் டு பெண்ட் அண்ட் கோயிங் டு அப்பியர் டு பி ரைஸ்ட் ஒன்லி, டெஃபினெட்லி, கரெக்டா? So by how much would an ink dot appear to be raised which is covered by a glass of thickness, glass plate of 6 centimeter thick, which is 6 into 10 to the power minus 2 meter thickness. Okay, and you know apparent, what is it? Refractive index. Formula is actual depth by apparent depth. Do you know refractive index of glass? It is 1.5 or 3 by 2. So then therefore you can write a 3 by 2 is equal to, the actual depth will be obviously the thickness of the glass slab itself. So 6 into 10 to the power minus 2 meter by apparent depth. With this you can cross multiply. 3 and 2 will get cancelled. 2 2s are 4. Apparent depth therefore is 4 into 10 to the power minus 2 meter. Apparent depth கிடைச்சிரும். Once apparent depth கிடைச்சிரும், apparent depthங்கிறது மேலேந்து இருக்கிற depth. கரெக்டா? But they will ask you how much is it appearing to be raised. அப்படின்னா இந்த distance கேட்குறாங்க. Appearing to be raised is actual depth minus apparent depth. Appearing to be raised in question வந்தா raised will be actual depth minus apparent depth. What is actual depth? 6 into 10 to the power minus 2. Minus what is apparent depth? 4 into 10 to the power minus 2. So 2 into 10 to the power minus 2 meters is the where it is appearing to be raised. They have written as 2 centimeter. Doesn't matter. You can write your own answer. Can I go to next question? Next question, let's do example 20. A glass beaker of height 10 centimeter